Yeah, I love doing math. You love doing math. We love doing math.
Hey, CVA Integrated Math 3 students, let's go over the Module 8 pretest / post-test. I want to give you some feedback based off those questions. Question number 1, which statement about the data is true? So I had length of newborn babies. Hey, I got babies, lots of babies, but let's go ahead and calculate these numbers and then we can write down some things. So to find the mean, I'm just going to add all of those up. So I'm going to go second stat, try that again, stat, edit, go up to the top of list 1, press clear, enter, and then I'm going to go ahead and input these numbers: 18, 19, 23, 20, 20, 19, 19, 21, 22, 22, 18, and 19. And that's a 4 by 3, so I have 12 there. So I'm going to go ahead and stat and calculate one of our stats. Remember, the default is already list 1. So if you just press enter, it'll give you, but if you really want to put in list 1, I'm going to press second 1, orange button, and then number 1. Okay, there it tells me X bar, which is 20, and then it tells me right there the median is 19.5. Here's another way you can do that. To get your median, you can go stat, sort, number 2, and under edit, sort ascending, and then put in list 1, second 1. And if you go back to your list, it's now put all of those numbers in list 1 in order. And so if it's 12 people, that'll be between the 6th and the 7th. So that gives you the 19.5. Whoops, where did we go? Oh, email, sorry, going all over the place. So the mean is 20 and the median is 19.5. Are they equal? No. If I'm going to put an inequality sign, I probably put greater than. So our answer is C. Number 1 is C. All right. Question number 2. Carlos would like to earn an 82% or better on his report card for the biology class. His test scores so far are 74, 76, 92, 86, and 80. Assuming the class grade is determined only by test scores, what must his last test be to earn an 82% or better in the class? Okay, so I'm going to add up all of these numbers: 74, 76, 92, 86, and 80. And this is the formula for an average. It's the summation divided by n. Summation means adding them all up. But what I'm going to do here is the last test, I'm going to call the variable x. And then the average that I need to find is an n value. That's the total number of tests. So let's go ahead and just count the numbers here. 1, 2, 3, 4, 5, 6. So we have an n equals 6. And we actually know what the average or x bar should be. We're trying to get a different color here. We're trying to get a score of an 82. Okay, so let's go ahead and just add up all those scores. So 82 equals, I'm going to add those on my calculator here on the side, 74 plus 76 plus 92 plus 86 plus 80 gives me 408 plus x divided by 6. Okay, the best thing is to get rid of our fraction is to multiply by the reciprocal, which is just 6 over 1. So you multiply by 6 or 6 over 1 on this side, and you're going to get 82 times 6 gives me 492. And then if I just subtract 408 from both sides, we'll get, let's see, 419 minus 408 gives me a score of 84. So if you add 84 to the list right there, and you add them all up, divided by 6, then your average will be 82. So question number 2, our answer is ooh, did I mess up? Should it be 84? Let's double check. 74 plus 76 plus 92 plus 86 plus 80 gives me that number, 408, and then 82 times 6, 492, and it should be 84. Okay. I need to change the answer on the pre-test, post-test Google form. So I'm recording this as of Tuesday, 9/28/2021, 2:43 p.m. Sorry about that. Okay, question number 3. Find the mode of the data. Select all that apply. Okay, so for mode, that just means the most. And we have to put them in order. So I see 3 22s. I see 24, 24, 24. I guess you don't have to put them in order. Why am I putting them in order? I guess it helps me collect the data or organize my data, which is fine. 25s. I see a 26. 27. Any 28s. 1, 2, 28s. And then I have some 30s and a 31. Okay, so I see that I have 3 of them here and 3 of them there. So that would be 22 and 24. So for question number 3, our answers are both A and B. Where's question number 4? Here's question number 4. If the chances of getting a sticker in a box are 1 in 8, what is the chance as a percent? So 1 in 8 is just 1 over 8. Let's put that in our calculators together. Get out of here. Second mode or quit. Clear. And 1 divided by 8 is 0.125. So, oops. And remember, this is a fraction to a decimal, and let's go to a percent. Percent, like how many cents are in a dollar? That's 100. So to go from a decimal to a percent, we're going to multiply by 100. And basically what that does is it moves the decimal place 2 places. So that would be 12.5% is our answer. And that would be choice B. Question number 4, our answer is B. Okay, let's go to question number 5A. There are 32 students riding the bus. Of the students, 12 are wearing sandals and 15 are wearing sneakers. Okay, first thing you should recognize is, okay, there's not all the students are listed there. So out of the students on the bus, what percent are wearing sandals? So remember, a probability or percentage is just your select over the all. So in this case, our select are sandals over all. So our sandals are 12 over 32. 12 divided by 32. That gives me 0.375, and then I'm going to multiply by 100. That'll give me 37.5. So my answer is 37.5, which is C. Okay, 5B. There are 32 students riding the bus. 12 are wearing sandals, 15 wearing sneakers. Which ones are not wearing sandals? Okay, so sandals plus no sandals is equal to all of them. I like to summarize it as yes plus no equals all. So if the yes sandals are 12, and then the all is 32, then the no's, pay attention, the no's is equal to 20. 20 of them are not wearing sandals. This idea is called a complement, and we just do it over the total. So 20 divided by 32, multiplied by 100, 62.5. And you could have taken that idea, duh me, what happened? Dun, 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 dun. Well, let's see. We could have done, out of all the students on the bus, what percentage are not wearing sandals? So that would be sneakers plus other, 5 others. So 12 are sandals, and 15 are wearing sneakers. So are not wearing sandals, I want this plus this. 15 plus 5 gives me 20. And 20 divided by 32 gives me 62.5. I have to check back at the answer key, but I'll rescore it once I know the correct answer, which we don't have right now. Okay. All right, I forgot some wording on question 5B. So it says what percent are not wearing sandals or sneakers? So sandals are 12, sneakers are 15. So what's not 27, but the other part, that would be the 5. And so that would essentially be 5 out of 32, which would be 15.6. So question 5B, the answer is 15.6. That means I skipped question number 6. Of the 564 customers that visit a grocery store, 57% bought milk. How many customers bought milk? So if you take the total number, n, and you multiply it by the percentage, which is 57.57, so you would get 564 times 0.57, and I'll just put on a calculator on the side right here. This number, which would give us C. Question number 6, our answer is C. Question number 7, Miranda has $30 to spend. Which of the following can she afford while it is on sale? Okay. So the sales price is equal to the original price times the percentage discount. Okay, so I'm going to say 1 minus the discount. So for example, $74 times 1 minus 0.55. And basically what that means is she's paying only 45% of the original value. So 75 times 0.45 will give me $33.33, which she cannot afford because she only has $30, so that one doesn't match. Let's do another one. So $58. So this is a good way for you to go to shopping. 1 minus 0.4, which would give me 0.6. That's multiplication there. So 58 times 0.6, and that would, try that again. 58 times 0.6. 34, 80, she can't afford that, she only has $30. And this one will be 90 times 1 minus 0.70. Okay, now I read that one wrong. Watch this. All of those say off. Off. So another way of doing that first problem would have been $74 and then 55% times this value. So the discount of 74 times 0.55 is $40.70. You get to take $40.70 off the original. So if you subtract those, you will get, 74 times 0.55 gives me $40.70. So subtract that from 70. How come I'm not getting my same number? Maybe I didn't multiply the first one. 75 times 0.45. So $74, that's why I can't write. $74 times 0.55 will give me 40.70. So 74 minus $40.70 will give me $33.30, which I have here. So essentially what the off means, you're just subtracting it, right? But this one just says $90 at 70% of the price. So this one will just be 90 times 0.7. And this will give you $63, but you can't afford that one either. So 13 means that, not 13, question 7. Maybe that was supposed to say 70% off. I have to double check my typos. Yeah, I think it's this one. I worded it wrong. My bad. Because it should have said off. Because it would have given me, okay, so, because this would give you 27, and then therefore she can afford $27. Typo, my bad. Let me change that right now. Okay, we did. Let's go on question number 8. Which event has a 25% chance of occurring? Remember, I'm going to do select over all. Okay, a coin has 2 chances, and heads is just 1. So that would be 1/2. 1/2 is 50%. So not that one. Selecting a multiple of 4 given the numbers 1 through 12. So multiples of 4, so count by 4s, 4, 8, and 12. And that means there are 3 out of 12, which gives me reducing it to 1/4, right? 1 times 3, 4 times 3, and then I cancel the 3's there, so you're left with 1/4, which is 25%, so that one matches. What? Oops, I did them out of order. That's question number 8. And then tossing a prime number on a dice. So on a die, there's 1, 2, 3, 4, 5, 6, and a prime number is 1 times itself. So prime, 4 times 4 is 2, and then 5, so that would be 4 out of 6, which would give me 2/3, which is 67%. So that's not 25. And then selecting a king, there are 4 kings out of a standard deck of cards, which is 52, and that would be 1 out of 13, which is not 1/4, so not this one. So our answer is B. Question 8. Let's go to question number 9. Cassia has 1 die and a coin. Determine the probability as a fraction, the probability of a 5 or 6, and a heads. Probability of a 5, 6, and heads. Okay, so this one's a little bit confusing. 1 die has the numbers 1, 2, 3, 4. Well, 3, 4, 5, and 6. And a coin has the probability of heads or a tails. So, if I want okay, the first thing we're going to flip is let's do this by colors. Let's just do the die. And there are 6 total numbers, and I can get a 5 or 6. So that's 2 chances. Does that make sense? Let me do it this way. 5 or 6 over 1, 2, 3, 4, 5, 6. All right, that would give me 2, 6. And then a heads, this would just be a 1 out of 2. And they're independent events, so you would multiply those. So that would give you 2 12s, which would reduce to 1 6 is your answer. And last question, number 10. True or false? The probability of selecting a heart or a king from a regular deck of 52 cards is 4/13. Okay, or means you get to add those. So there are 13 hearts and there are 4 kings. Okay, but there's a duplicate. There's 1 card that is both a heart and a king, so you have to subtract that. So that would be, if you think about it, there's 13 hearts, and one of those is a king, so it's 13. And then you're subtracting that duplicate, so that means there's only 3 of spades, clubs, and diamonds. So that would give you 16 over 52. And if you divide that in half, you get this. And divide it again, blah, blah, blah. 13 times 2, and you would get 4/13. So that would be true. True is the last one. I hope that was helpful for you guys. We'll see you later. Bye.
24 hours in a day, and I get to do math, hey hooray. Y equals mx plus b with Mr. Ng, we're making history. Pythagoras, Euclid, and Gauss learn the math and you'll become the boss.